Oh, hello everyone. Just talking about LEDs today a little bit. The idea of how you can get light in a different way. Um, the old way so LED stands for light emitting diode. It's an electronic device, and we use them all over the place to be able to get light. Now, in the past, we have been able to go and get light through incandescence, light from a heated object. So fire. Being able to take an old-fashioned light bulb, it gets hot on the inside, and for those of you who can remember all the way back then, those bulbs get really, really hot. Um, and so there's essentially a piece of metal on the inside that glows white hot. Electroluminescence is a different way of producing light. LEDs do this, light from the flow of electrons. No heat is involved there, or very little heat is involved. So they are much more efficient, actually, if you think about, because we got new LED type lights and things like that we use in our house. I call them new, but you know, but back in the day, we were using incandescent bulbs and such. Incandescence can also be represented by that demo called the limelight. So, where do we go with this? Well, LEDs, let's see here. Development of LEDs. Well, let's see. We got some right here. You should have a little cup with a battery and some LEDs in it. And let's take a look here. Let's write down a few ideas here. LED technology. Let me think about this. One of the big ideas is that our modern electronics uses metalloids. Now, what are the metalloids? The metalloids here are pretty much right along this line. There's this dividing line on the old periodic table between the metals. Pretty much everything down this way are metals except for hydrogen. It's an oddball. And then over here, the nonmetals. Okay? So these nonmetals, they're different from one another in that the metals tend to be shiny and bendable and conduct electricity really well. Nonmetals tend to be not shiny. They tend not to conduct electricity very well. A good example of... Where did I put that thing? Oh, right here. Right here in front of me. A good example of a metalloid. So along this dividing line, right down through here, we have materials that have properties of both. And so good old silicon is a good example of that, and that's what I have right here. Silicon, though it looks shiny and it feels cold to the touch, doesn't conduct electricity very well. And also, I don't know if you can see, but it will fracture. It will break like a rock or really hard glass. So this thing doesn't bend. It cracks and shatters. So it has some of the properties of being a nonmetal and some of the properties of being a metal. And that's why it's along this line here. And it's totally important because this is where we get our everyday electronics from, is really the electronics in your phone, the electronics, everything pretty much since the 1950s has been, well, 50s, 60s, definitely in the 60s, electronics was based on silicon. And silicon, not silicone, but silicon is what gives us the electronics that we have nowadays. So, just starting off here, let's see, 1962, they came up with this technology called GASP. Okay, so that's gallium arsenide phosphide. And so gallium is right here, and arsenic is right here, and phosphorus is right here. By combining these three, gallium, arsenic, and phosphorus, they were able to create the first red LED. So let's pull this on out here. And you guys can pull that on out and play with it. I want you to play with these things here a little bit. This is a little battery, and the backside's positive. Now, when you use one of these LEDs here, okay, the longer one has to be on there. If you flip it around the other way, it won't do anything, right? Electricity flows through it in only one direction, and you get a nice red LED there. And so, 1962, GASP, gallium arsenide phosphide. And notice these are on either side of this sort of dividing line between metals and nonmetals. And so, oh yeah, and that gave us the good old red LED. 1970s, we were able to get a whole bunch more. So they developed a whole bunch more, and it was gallium phosphide was the technology. GAP. And if we just go and say gallium phosphide, just using gallium and phosphorus right there, connecting those on up, we were able to get, by adding different impurities beyond the gallium and the phosphorus, but they were able to go and end up with red, yellow, and green. Which is great. And what do we got here? Another type of red was able to be produced. Boom. Pretty. Fun to play with. And good old yellow. Whoop. Nice to play with. Fun. And green. Okay. And that's the sort of stuff I grew up with, was this stuff. Red, yellow, and green. But they had not, through the 1970s, they had not been able to come up with the blue LED. And that was the holy grail. And it wasn't until 1993. So you're here in the 1970s, push it later on, 1993, the first blue LEDs were produced. And the technology was indium, gallium nitride, and that led to blue LEDs. So we had indium connected with gallium, connected with nitrogen, and other impurities. Now, you don't have to, when you're taking down the notes on this, that's great, but the thing that I really want you to see is, like, we talked about the metalloids and how we can take stuff from either side of the metalloid and combine them together so that they can start acting like a metalloid. Remember, metalloids are the key to our electronics that we have today. The computer chips, this is actually computer chip grade material. So no LEDs are made out of this. The silicon there isn't suitable. It gives off a color of light that you can't see. Yeah, that got chipped right there. Anyway, so blue LED. Oh, yes. And then let's put this on up here, the good old blue LED. And it's interesting. So the reason why this was the holy grail, so to speak, was that you needed 3 colors. Good old red, green, and blue. And so these 3 colors, red, green, and blue, are the only colors that our eyes are actually sensitive to. In the back of our eye, we have sort of 3 different buttons to push. One for red light, one for green light, and one for blue light. By the brightness being different on those, we're able to go and see different colors. Other odd and different colors that we see all around us, all the huge myriad of colors. If you ever look close at your screen on your cell phone with a microscope, you'll see that you only have red, green, and blue coming off of your cell phone. There are LED TVs and organic LED TVs, but the point is that they use red, green, and blue to be able to make When you mix them all together, now you've taken art probably where you've mixed paints. This is different. Mixing paints and mixing light are different ways of thinking about color. When you mix red, green, and blue light together, you can end up with a good old white light LED. And that's something that's turned into all of our flashlights that we have, even headlights. And this was like I said, it was kind of getting all those together, red, green, and blue together, to be able to go and produce the LED lighting that we have now today, which is so much more efficient than the LEDs of the past. Anyhow, well, that's all for right now. Thank you so much.